Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one of the GATE question which came in the year 2017 related to scheduling algorithms. This kind of question will help you to understand the concept in a better way and also useful to know what kind of questions you can expect in various competitive exams related to scheduling algorithms. So I request everyone to watch the complete video for better understanding. First, let me read out the question. Then I will discuss the solution with you. Look at the question. Consider the following processes with arrival times and burst times in milliseconds as given below. They have considered four processes which are P1, P2, P3 and P4 with arrival time as 0 milliseconds, 3 milliseconds, 5 milliseconds and 6 milliseconds respectively, having burst time as 7 milliseconds, 3 milliseconds, 5 milliseconds, 2 milliseconds. If the preemptive shortest remaining time scheduling algorithm is used, then the average waiting time is. They have given four options, option A, option B, option C, option D. We need to use the preemptive shortest remaining time scheduling algorithm and draw the Gantt chart and find out the completion time of each process, turnaround time, waiting time. Then we need to compute the average waiting time. Now, what is the scheduling algorithm they are using? They are using the preemptive shortest remaining time. It is shortest remaining time, meaning is that you need to consider the burst time and it is preemptive in nature. What is meant by this one? Let's assume that at a time instant, process P1 is in the ready state with 3 burst time. Some processor P2 is running in the running state, okay, with 4 milliseconds burst time or 4 units of burst time. Now one processor is in the ready state, another process is running. Now it will look at the burst time of the process which is there in the ready state and running state. Now which one has the less burst time? Because it is shortest remaining time. So shortest burst time, this is having 3 burst time and this is required 4 units of burst time. Now which one is shortest? This one. So then it will be preempted, meaning is that it will be the processor P2 will be shifted to the ready state and processor P1 will be bring into the running state. So then P2 will come to the ready state and P1 will be come to the running state and it will start executing its task. Okay, so we need to consider the burst time of each processor. As it is a preemptive, we need to consider the process which are there in the ready state and running state also. Now let me draw the Gantt chart. The Gantt chart always starts from 0 milliseconds because they have considered the time with respect to this milliseconds 0. So I am considering it as 0 milliseconds. Now at 0 milliseconds, look at how many processes have been arrived. Meaning is that how many processes are there in the ready state. Only processor P1 is in the ready state which requires 7 milliseconds of burst time to complete its task. So what I will do is that I will shift this processor P1 to the running state and it will start executing it. Okay, now there is no other processor in the ready state. So what I will do, I will run the processor P1 for 1 millisecond, then its remaining burst time is 6. Okay, is it clear? Are you able to understand? Initially it was 7, now it requires only 6 milliseconds to complete its task. By that time, any other processor is arrived in the ready state? No, because this processor P2 will arrive at 3 milliseconds, P3 will arrive at 5 milliseconds, processor P4 will arrive at 6 milliseconds. So, again I can execute the processor P1 for 1 more millisecond. It completes its 2 units of burst time and 5 units are remaining. Okay. Now at 2 milliseconds, any other processor has been arrived? No. So again you can execute the processor P1 for 1 millisecond. Okay, so totally we have executed the processor P1 for 3 milliseconds. So it needs remaining 4 units of burst time. Is it clear? By that time, 3 milliseconds processor P2 has been arrived to the ready state. Okay, its burst time is 3. Now it will look at it. The processor which is running in the running state requires 4 units of burst time, but the processor P2 which is in the ready state needs only 3 units of burst time. So this one have the less burst time as compared to the processor which is in the running state. So what you need to do, you need to do the context switching. So the processor P1 will go to the ready state and processor P2 will be shifted to the running state. Okay, are you able to understand? So its burst time is 3 units. So we will run it for 1 millisecond. Okay, so its remaining burst time is 2. Okay, its remaining burst time is 2. Look at here, processor P1 requires 4 units of time and processor P2 requires another 2 units of time to complete its task. By that time any other processor has been arrived? No. So still processor P2 burst time is less as compared to the P1. So P2 will execute for another 1 millisecond. So its remaining burst time is 1 millisecond. Okay, by that time processor P3 has been arrived to the ready state. Its burst time is 5 units. Is it clear? Or 5 milliseconds it's required. Now again compare the processor which is running in the running state and the process which are there in the ready state. This processor remaining burst time is less as compared to the two processes which are there in the ready state. So it will complete its task for 1 more millisecond. At 6 milliseconds, it has completed its task and it will go to the terminated state. Is it clear? Because we will have new, ready, running, terminated, wait, suspended wait and suspended ready. These are the 7 states in a process state diagram. So after running, if it's completed, it will go to the terminated state. Okay. So processor P2 has completed its task. Now by the time processor P4 has been arrived and its burst time is 2 milliseconds only. Now look at the process which are there in the ready state. P4, P1 and P3, their burst times is 2, 4, 5 respectively. Among these 3 processes, which is having the less burst time? Processor P4. So that will be shifted to the running state. Okay, are you able to understand? So it will be run for 1 millisecond. Then its remaining burst time is 1. Still it is having the less burst time as compared to the process which are there in the ready state. So we will execute for 1 more millisecond. So it has completed its task and it will go to the terminated state. So two processes which are P1 and P3 are in the ready state with having the burst time as 4 milliseconds and 5 milliseconds. Among them P1 is having the less burst time, so it will be shifted to the running state and it will complete its task for 4 milliseconds, because even if you run for 1 milliseconds, after executing 1 milliseconds this remaining burst time will be 3, which is less than P3. So you can run the P1 for 4 milliseconds from 8 to 12 and then processor P1 will complete its task and will go to the terminated state. So only one process is there in the ready state. It will be shifted to the running state and it will complete its task from 12 milliseconds to 17 milliseconds. Then processor P3 also will be gone to the terminated state. So we have completed the drawing the Gantt chart for the given question. Now we need to find out the completion time of each process. Look at the processor P1 completion time. When it has completed its task at 12 milliseconds, so you draw the 12 here. And processor P2 has completed its task at 6 milliseconds. Okay, processor P3 17, processor P4 at 8 milliseconds. Okay, we got the completion time of each processor. Now we will compute the turnaround time. Turnaround time is equal to completion time minus arrival time. So which is 12 minus 0 will be 12, 6 minus 3 is 3, 17 minus 5 is 12, 8 minus 6 is 2. So this is the turnaround time of all the process. Now we need to compute the waiting time. Waiting time is equal to turnaround time minus burst time. So 12 minus 7 is 5, 3 minus 3 is 0, 12 minus 5 is 7, 2 minus 2 is 0. So we got the waiting time of each processor. Now what they're asking, compute the average waiting time. How can we compute the average waiting time is, find the sum of all the process waiting time and divide by the number of process. So which is nothing but 5 plus 0 plus 7 plus 0 by 4, which is equal to 12 by 4 is equal to 3 milliseconds is the average waiting time. So the option A is saying 3, which is correct. Option B, option C, option D is wrong. So for this question, option A is the correct answer. I hope you have understood how I solved this question. If you still have any doubts related to this question, feel free to ask me in the comment section. If you find any other gate questions or UGC net questions related to any scheduling algorithm, please post it in the comment section. I will solve it and upload the video for you. Thank you for watching the complete video. Have a nice day.